said what I said. Yeah, Monk, I tried your glasses.
Let's get our notes out.
I don't think they're real.
What kind of shirt is that you're wearing?
It's a non-uniform shirt.
Mm-hmm.
I've been to that college before.
I'll take it.
Yeah.
I'm okay with them.
All right. So yesterday we were talking about vector coordinates and finding them and finding the magnitude. So we got a couple more to do. Let's do those. So we're on our notes, page 49. That's the first page. And we're ready for 3C.
New enough, bro. Did you say little guy?
It's funny how it's fun.
Hey, I heard you squat with 10s on the bar. Yeah? Nice, bro. I heard it's fat.
You need spot.
I heard it's out.
All right.
45 on the bar.
Stop.
7.
That's still weak.
Huh? 5.
All right. So Jalen, Judah, Chase, everybody's quiet over there, right? We're all paying attention. Eating our donuts, filling your mouth. Good. Okay. Directions say find the components. So that means find PQ. You remember this from yesterday? To find from P to Q, we either just kind of use our common sense, -6 to +1, or that's 7, or you can do like you're doing slope and actually subtract. So it'd be -3 -2 and 1 minus -6. So there's where the 7 comes from, and then my y would be -5, which makes perfect sense because you're going from 2 all the way back to -3. So that's a movement of -5. I just use my common sense and count. If you want to do the slope thing, that'll work every time. Just remember that this is y and this is x. So this is x and this is y when you write it in your ordered pair. Now, what did we say yesterday about the magnitude of this? That's your notation for magnitude.
It's
Square root of.
You square root what?
square root of x squared plus
X squared plus y squared. That's exactly right. So the coordinates that you just found, you just square each one of them, add them up, and take the square root, so we get the square root of 74, which doesn't break down, so that's just it. So how do we find magnitude? Square the first number, square the second number, add them up, and take the square root. So, same thing, repeat, PQ, what are the coordinates here? -2 to 6 would be 8, and 4 to 1 would be -3. So the magnitude will be the square root of
73.
64 plus 9, which is the square root of 73. Perfect. Page 1 done. Now, page 2 here, or the back of page 49, has a bunch of little vector operations. All right, so here we go. Problem number 1 says we're going to add u and v together. Now, when we add u and v together, I wonder how we do that. Anybody have a wild guess how we might add those together?
Find the magnitude of that,
You don't have to do the magnitude.
but then you just.
You just add the x's and add the y's.
Yeah, that's it. You add the x's and you add the y's. So if I add the x's, I get -1. If I add the y's, I get -1. Kids, it's just like you do with matrices. How did you add matrices? Didn't you add the numbers in the same spots? So how do we add vectors? We add the numbers in the same spots. So we add the x's, we add the y's. Harry, you haven't been in this class long enough to sleep, buddy. You got to earn your right to sleep.
Have I earned that?
No.
Wide awake.
He's He's wide awake.
Yeah.
All right, well, sit up and look wide awake. You look like you're sleeping to me. All right, B, or 2, or B. How do you think we do this? How do we do this? Take a wild guess. Multiply everything in V by 3. And guess what 3 is called? A scalar. Same vocabulary in matrix land as in vector land. So the answer, just take everything in V times 3. This, you already know what this means. What did we say that meant?
Same thing.
What's that mean? Magnitude. So here's U. How do we find the magnitude?
So 9.
9 plus 1.
He said that there.
So the magnitude is root 10. How do we find the magnitude of a vector? We square the x, square the y, add them together, and take the square root. Right? Okay. Let's see, what was that? All right, D. How do you think we'll do D? So we're going to have negative 3, 1, that's U. And now we have to add 2V. So 2V would be 4, negative 4. Now we're going to add them together. Jalen, I need you up here, right here, right now. So we're going to add those two together. And so our final answer will be 1, negative 3. Is that okay with everybody? E says V minus W. So that's 2, negative 2 minus 0, 3.
2, negative 5.
When we subtract, we do it just like we do when we add.
3.
So it's going to be, I'm going to subtract, so it's going to be 2 minus 0 and negative 2 minus 3. There's our answer. When we add with the vector coordinates, we just add the x's and add the y's. When we subtract the x's, subtract the y's. Easy. What do you think this means?
Negative 2 is the answer.
The answer is negative 2, 2. You're exactly right. Because what are we doing to U? We are making it the opposite?
Isn't it? Wait, which
Oh, wait. I did V. It's supposed to be U. You're right. Is that U? Yes, I'm sorry. I used the wrong vector. So it's 3, negative 1. Is that better? It's the opposite of U, not V. I did the opposite of V. It's the opposite of U.
U minus.
So the opposite of U. Now with G, let's do what we always do. Let's start inside. These aren't really parentheses, but let's start inside of them. So what would U minus V be?
Negative
U
5.
minus V would be negative 5, 3. Now, what do those bars mean?
Absolute value.
Well, the notation's absolute value, but what it means is magnitude, right? And how do we find the magnitude? It's a square root of 25 plus 9. Remember, how do we find the magnitude of a vector? We square the first one, square the second one, add them up, and take the square root. Anytime we see this notation, looks like absolute value, we know we're going to be finding magnitude. So square the first one, square the second one, add them up, and take the square root. All right, and one more in this section, 2U plus W. The magnitude. All right, so let's start inside first. So 2U would be negative 6, 2. right? 2u. And I'm going to add w. So that's going to give me a grand total of what?
-6. Oh, wait, no.
No, it is. It's -6, 5. Remember, we add the x's and we add the y's. Now, we still have to do magnitude. So what does that mean I have to do?
36 plus
Square root of 36 plus 25. So the answer is square root of 61. Coincidentally, none of our radicals have reduced, but if they would reduce, for example, if this had been the square root of 80, you would want to break it down. Okay? Break them down if they reduce. None of ours have reduced. So, that little section, that's easy stuff. To add them, you just add the x's, add the y's. So the same thing with subtraction. Magnitude means square the first one, square the second one, add them up and take the square root. If we put a scalar out in front, it just means multiply both parts of u by 2. Everybody got that okay? All right. Then the next section says, find a unit vector. Now, what does that mean?
Just wants the vector for the single root, right?
Kids, what is the magnitude of this vector? Let's find the magnitude of this. What is the magnitude of it?
4,
5.
2.
I've heard 2, 4, and 5.
It's 2.
It's the square root of 5. One more time. To find magnitude, you square the first one, square the second one, add them up, take the square root. Every time. So this vector, if I were to draw a picture of it, is root 5 long. I want it to be a unit vector. And a unit vector is a vector whose length is 1. So my vector is too long because my vector is root 5 long and I need it to be 1 long. This is so easy. Just take your two coordinates, -2 and 1, and divide them by root 5. Now I know that's not simplified, so we're going to simplify it in a minute. You know what I'm talking about, getting rid of that radical on the bottom. But that is the unit vector. That's all there is to it.
You know,
So how do we find a unit vector? We just take our original and divide each piece by its magnitude. Okay? So what's my final answer? Remember how we do this? -2 root 5 over 5 and root 5 over 5. That's it. That's all there is to it. It's as easy as can be. All right, so Chase Stewart, using the one I just did as an example. Okay, do you understand the steps here? Now I'm going to do the same thing. I'm going to find a unit vector for this guy. So what is step 1? What do I have to do first? I got to find its magnitude. So the magnitude of this vector will be the square root of 36, 4. So that's going to be root 40, which reduces to 2 root 10. That's not your answer, folks. Remember, how do we find our answer? We have to take these numbers and divide them by 2 root 10. Oops, that's not negative. So 6 over 2 root 10 and -2 over 2 root 10. And now we're going to start simplifying. Now, before you start messing with the root 10s, can you see a simplification right here? So I'm going to cancel that out and make this a 3. Right? So then I've got 3 over root 10, which is 3 root 10 over 10. And negative 2 root 10 over 10.
Yeah,
What?
you forgot the other two. It
Oh.
should be negative 10 over 10.
And those cancel, you're right. I'm so excited about Pi Day, I'm making mistakes left and right, so good thing you guys are here to catch me. So there, I divided by 2 root 10, so those 2's cancel. Left me with my negative 1. And I think that's my answer. I think I'm done simplifying. Two more.
Save me cookies for later. Don't be throwing away.
We're gonna make it a unit vector, so what's the first thing we do? Find its magnitude. So its magnitude will be the square root of 0 plus 16. That's just 4, isn't it? So the length of that vector is 4. So what will be the unit vector? Take both of these and divide them by 4.
0, 4, 1.
So 0 and 1. So the answer is 0 and 1.
That's really nice of you.
Alright, and the last one in this section. So I need to find its magnitude. So its magnitude will be what? 9 plus 16. Which is the square root of 25, which is just 5. Now what do I do? Divide by 5. So my answer is negative 3/5, comma, negative 4/5. Now all of those problems that I just did, what were the directions? Find the unit vector. So when you are asked to find a unit vector, you just take the original coordinates and divide them by the magnitude. That's how you find a unit vector. It's that easy. Okay? There are reasons to find a unit vector too. We're probably not going to get into them, but unit vectors are important. All right. Speaking of important, take a look at this. This is a vector. This vector is making a 37-degree angle with the x-axis, and its magnitude is 16. So this would be a situation like if I were pushing down on this chair like to push it, and if I had 16 pounds of force, pushing it with 16 pounds of force at an angle of 37 degrees. That's what's happening right here. Okay? We have a vector acting against the horizontal, and the angle it makes with the horizontal is 37, and its magnitude is 16. And your job is to find the components. Now remember, these are components, or coordinates. Coordinates, components, same thing. So your job is to come up with this. You know how to do it already. Aren't these X and Y? So if you look at that picture and you envision your butterfly bow tie, this is X, isn't it? Isn't that X?
Yeah.
And this is Y? Think about your trigonometry. Can we, what?
SOHCAHTOA.
SOHCAHTOA. That's it. It's all SOHCAHTOA. That's a right triangle. It doesn't matter which one we find first. I find them both. So let's say I want to find x first. Sine, cosine, or tangent to find x. Let me get this out of here. I'm finding x. Sine, cosine, or tangent.
Sorry.
Cosine. Why is it cosine?
Adjacent.
Because this is adjacent and that is hypotenuse. So the cosine of 37 equals x over 16. SOHCAHTOA. Adjacent over hypotenuse. Cosine angle equals adjacent side over hypotenuse. So we'll find x by multiplying by 16. So 16 cosine 37, 12.78, I have to round it off. Is that okay? And then how about y? How am I going to find y? I'm going to do exactly the same thing, but I'm going to use sine. So sine 37 equals opposite over hypotenuse. And 16 sine 37 equals y. .63. So you were given an angle and a magnitude. And from that, you used your trigonometry to come up with the x and the y. A little foreshadowing here. You might think of that as an airplane flying on a heading. And we want to know how far east and north he is from where he started. So this would be east, that would be north. All right, let's try, there's another one. This one's going to be a little bit tricky if you're not paying attention. So we're all in our donut comas, but we got to pay attention here. Yeah. Corey has already picked up on it. We can do the same thing. We can drop this butterfly bow tie. This is x and this is y. But the x this time is going to have to be negative. And I know that it's not going to come out on my calculator, kids. It's not going to come out on your calculator. You're going to have to pay attention to the picture. X is a negative number. So I'm going to set it up the same way. Cosine 40 equals x over 10. And sine 40 equals y over 10. Does that make sense to everybody?
So you wouldn't make the x negative?
I'm going to when I'm done. Yeah, it's not, I'm not going to make it, I mean, I guess you could. We usually wait till we write our answer and then whatever we get, we make negative. But if you wanted to make that negative right now, you could, it wouldn't hurt anything. So 10 cosine 40 is going to be my x value, and 10 sine 40 will be my y value. And then at some point, I got to make the x negative. Just make sure the x you write down is negative. Okay, negative 7.66. Now y is not negative. Does everybody see that? We're not making the y negative in this problem. Y is positive. If I plotted this point right here, x would be negative and y would be positive.
That was
I know. All right, let's go to C. Let's go to C. problems are exactly the same. Come on, guys, we have a couple more sections we gotta get through. All these problems are exactly the same, except they're in different quadrants. So the only thing that's gonna change in our strategy is where we end up putting negatives. What's gonna happen on this one? They're both gonna be negative, right? I'm gonna find them the same way as always. Cosine goes with x. Does that sound familiar?
Cosec.
Cosine is x over r. Cosine goes with x. So cosine 31 equals x over 8. And sine 31 equals y over 8. I'll type them in on my calculator, making them both negative. Double check me and make sure I match what you had. Bingo. And then we have one more. What's going to be negative here? Y. I mean, yes. Now I'm not asking you. Yes, you're right. Y is the negative one. Do you remember me harping on you that if you're not in quadrant 1, something's negative? That hasn't changed. If your vector isn't in quadrant 1, then make sure you're marking something negative. So in this case, it's going to be our y. So cosine 15 is x over 100. Sine 15 equals y over 100. Everybody got it? So 100 cosine 15 and 100 sine 15. I think that's pretty easy. All right, Megan, got all this?
Yeah.
Not too bad. Now we're going to do the exact opposite. Actually, this one isn't the opposite. Never mind. This is the same thing. It's just worded differently. We have an airplane flying on a course of 200 degrees. All right, dig back in your memories. This is a compass.
You skipped a ton.
Oh, I skipped something?
Find the magnitude.
Oh, yeah. I'm sorry. So, yeah, we'll do that in a minute. Let's do 7 first. Actually, we may have to wait and do that next time. Now we're going to do part 7. Sorry about that.
I think.
This is the opposite of what we just did. So we have the vector 3, 2, and we need to find its magnitude and its direction. Now, I just erased it, but we had a vector that was 100 long at an angle of 15 degrees, and we found the x and y for it. Now we're going backwards. So we have a vector that goes over 3 and up 2. And we need to find its magnitude. That's easy. What's its magnitude? You know that already. You know how to find that. What's the magnitude?
13.
The square root of 13. How do we find magnitude? Square the first one, square the second one, add them together, and take the square root. So that's review. You know how to do that. But now I also need the direction angle. Any ideas how I might find that? The Pythagorean theorem will give me this. I need an angle though. How do I find angles on my calculator? Do you remember? Second. So in other words, I know if I call this angle theta or x or something, call it something, I know that its tangent is 2/3. Would you agree with that? The tangent is opposite over adjacent. So what will I press on my calculator to get the angle? Second tangent 2/3. And that angle is 33.69 degrees. So you were given over 3 up 2. You used your magnitude formula or the Pythagorean theorem or something to find root 13. That was the magnitude. To find the angle, we had to second on our calculator. So to find the angle, I second tangented 2/3, right? And that gave me 33.69. This next one's tricky. Now, can you draw -1,5? I hope so. -1,5 would look like this, right? Sophia?
Would it be tangent for all of them?
Yep. Because as long as you're given the x and the y, you've got opposite and adjacent every time. Yep. Now, since I figured this was root 13, could I have used a different function? Yeah, but then I'd have to mess around with the root 13. So I'm just going to use the given numbers, and yes, it will always be second tangent. Always. All right, picture okay? What's the magnitude? Square root what? Not 6. 26? Remember, we have to square, add them up, and square root. So the magnitude is root 26. Now, can we find this angle right here? Yes, because we know its tangent is 5/1. With these guys, I tend to not put the negatives in because it's just going to give me a negative answer, which I'm just going to drop that negative anyway, because this is not a negative angle. So you don't need that negative. If you put it in, fine. You're going to get the same angle I do. I'm going to second tangent 5. And my angle is 78.69. Now, that is not the direction angle, because the direction angle starts here. How in the world am I going to figure out what that green angle is? Subtract from 180. So I'm just going to take the angle I got and subtract it from 180. So my direction angle is 101.31 degrees. That is tricky. I get it. It's tricky.
So, what would that indicate that if it's on a negative side?
If any angle that's not quadrant 1 is going to have to be finagled. So in this case, we finagled it by subtracting from 180. But that isn't the way we'll handle all of them. It depends which quadrant you are in.
The bottom one would be 360, right?
So let's work through these. So we look at the next one. Now we're down here, -3, -6. Okay? So what's the magnitude? We can find our magnitude easily enough. It'll be the square root of 9 plus 36, 45. 3 root 5. Is that okay? Now I'm going to focus on this angle first. I know that angle is not the final answer. But what do I know about that angle? Its tangent is 6/3. Opposite over adjacent. So the angle is second tangent 6/3, 2. So second tangent 2, 63.43. Now if you get that, you're going to get partial credit because you are in the right ballpark. But you're in the wrong quadrant. 63 is this angle is not 63 degrees, and that's the angle that you want. So this time, how will I find that big red angle? Follow your pen. How far is it from here to here? 180, and you're going an extra 63. So wouldn't it be 180 plus 63? Those of you messing around with 270, here's 270. Does that angle have anything to do with 270? No, it's not touching it, it's not anything. 270 is not part of this. It's 180 plus 63. So that would be, your direction angle is 243.43 degrees. Right, one more. One -4. So plot the original point, and I make my butterfly bow tie with the original point. So over 1, down 4. Mason, what is my magnitude? Somebody remind him, how do we find magnitude?
Square the x, square the y, add them together.
So, square the x, root 17. So your magnitude is the square root of 17. Now, let's find this angle. As Sophia said, we're going to use tangent, opposite over adjacent. So we know the tangent of the angle is 4/1. Take or leave the negative, I don't care. It just gets in the way. I don't use it. It's not going to hurt anything if you put it in, just drop it out. So the angle is second tangent 4. $75.96. Now, if you put 75.96, you'll be wrong because the direction angle is this one.
So it's 3. This one is when you use 360.
Yep. So isn't that angle touching 360? So we're going to do 360 minus that. And it's 284.04. So our direction angle is 284.04 degrees. Oh my, we covered a lot of material.
And we ate pie.
And we ate pie.